Okay, so here's this problem. So if f of x equals this, which of the following is not true? So part A, f is continuous for all real numbers. So we want to, if that is true, we're going to cross it out because they want to know which is not true. So guys, the only thing that would prohibit this from being continuous, okay, so basically we want to ask, can we plug in any real number? And the answer is actually yes. Okay, so the way that, if you convert this like to radical form, so 1 plus, that'd be the cubed root of x squared. You can plug any number in here. You could plug a negative in, you could plug a positive in. The square is going to make it, so yeah, or actually you could also write it like this. Okay, so even like without the squared, guys, taking an odd root, like a cubed root or a fifth root or a seventh root, you can do that with a negative number. If this was a square root, then you could not plug negatives in because you can't take the even root of a negative number, but you can take the odd root of a negative number. So we can plug anything in there. So this is true. F is continuous for all real numbers. So I'm crossing it out because they want the thing that's not true. So F has a minimum at x equals 0. So let's see, let's take the derivative. For all the others, we do need the derivative. So let me take the derivative. So F prime of x is 2/3 x to the negative 1/3. Okay, now, so guys, this is 2/3 and then cubed root of x. So the critical numbers are where the derivative is 0 or undefined. So f prime undefined at x equals 0. Now, I can't use the second derivative test because that only works if for f prime equal to 0 and then f double prime positive or negative. The second derivative test does not work for f prime undefined. So we've got to go right to the number line, plug in 0. I can plug in like -1 and +1. If you plug -1 into here, you're going to get a negative number. The cube root of -1 is -1. So you're going to get a negative number, and then you plug 1 and you get a positive. So going from decreasing to increasing, so f prime from negative to positive means f goes from decreasing to increasing, so that would indicate a minimum. So that is true, so I'm crossing it out. F is increasing for x greater than 0. Yes, that's true. F prime exists for all x, not true. It does not exist for x equals 0. F prime is undefined there, so we found it. So I don't even have to test E. Okay,